Welcome to The Explainer. Today, we're going to meet four of the most fundamental numbers in the universe. Now, they might seem totally unrelated at first, but as we're about to see, they share a secret, and honestly, an incredibly beautiful relationship.
So let's just dive right in with what a lot of people call the most beautiful equation in all of mathematics, Euler's identity. It links these major constants together so simply, it almost looks like a mistake, right?
I mean, at first glance, this makes absolutely no sense. It feels like a total paradox. How can a number that goes on forever, raised to an imaginary power, land so perfectly on a simple -1? Well, to solve this mystery, we really need to get to know the characters involved, and each one has its own incredible and surprisingly human origin story.
Okay, our first character is Phi, who we'll call the artist. This is a number that seems to be hardwired right into our sense of beauty and design. You see it popping up everywhere, from ancient sculptures to the spiral patterns in nature.
It's named after the Greek sculptor Phidias, who supposedly used this exact proportion in his work. And mathematically, phi comes right out of the geometry of the pentagon, a shape the ancient Greeks thought was connected to the cosmos itself.
And this is where it gets really cool. You can see phi's unique personality in action right here. If you take a special kind of rectangle, a golden rectangle, and you slice out a perfect square, the little piece that's left over is another, smaller golden rectangle. And you can do this again and again forever, creating this gorgeous spiral of squares that curls inward toward a single point.
And like a lot of these special numbers, its value is irrational. What that means is that its decimal just goes on forever, without ever repeating a pattern. It's a number you can never quite pin down completely.
And get this, phi isn't just about geometry. It also shows up in number sequences. Now, a lot of us have heard of the Fibonacci sequence, but it was actually described 50 years earlier in India by a scholar named Hemachandra, and he found it while counting the possible rhythms in Sanskrit poetry. How amazing is that?
All right, let's move on to character number 2. Pi, the tireless engineer. Pi wasn't really born from art or poetry. It came from a practical, real-world need to measure circles and, well, build a world around us. At its core, pi is the number of circles, but its importance is everywhere. I mean, look at nature's best engineers, bees. To get the most honey storage with the least amount of wax, they build these perfect hexagonal honeycombs, which just happens to be the most efficient way to pack circles together.
You know, the quest to calculate pi is really a story of incredible human ingenuity. For centuries, brilliant minds like Archimedes and Liu Hui trapped pi between polygons with more and more sides. Later on, thinkers like Nilakantha in India discovered these amazing infinite series that could zero in on its value.
But those early formulas, as beautiful as they were a huge engineering challenge. This series, for example, is so simple and elegant, but it creeps up on the true value of pi at a snail's pace. You need something like 10,000 terms just to get the first few decimal places right.
Our third character is E, the naturalist. Now, this number doesn't come from static shapes like pentagons or circles. It comes from the dynamic fundamental processes of growth and change that we see happening all around us.
In fact, we can actually discover E with a simple puzzle. Imagine you have $10. If you split it into two parts, 5 and 5, their product is 25. Simple enough. But what if you split it into more parts? How do you get the biggest possible product?
So as you increase the number of parts, the product gets bigger. 2 parts gets you 25. 3 parts gets you about 37. 4 parts gives you 39. But it doesn't just grow forever. The product actually peaks when the size of each part gets really close to a very special number, the number we now call E.
And that's what E really is. It's a mathematical constant of continuous growth. It's the rate of growth that happens when something is growing at every single instant. We're talking about compound interest, a population of cells, radioactive decay. It's the same fundamental principle.
And now for our final character. This one is the most mysterious, the most misunderstood of them all. I, the chimera. This is a number so strange that for centuries, mathematicians thought it was monstrous, literally impossible.
I mean, think about it. The square root of a negative number. What number times itself equals -1? There's no simple answer. For centuries, this was just a dead end, and mathematicians called the whole idea chimerical after that mythical beast made of different animal parts, because it just didn't seem to belong in reality.
But this impossible number didn't just appear as a brain teaser.
It was actually born from a really frustrating real-world problem. Back in the 16th century, mathematicians were trying to find a formula to solve cubic equations, and they kept hitting this weird paradox. Sometimes, the only path to the real, sensible answers was to temporarily work with the square roots of negative numbers. The huge breakthrough came when mathematicians stopped trying to cram I onto the normal number line. They realized, what if it's not a number that's less than nothing? What if it's a number in a completely new direction? And just like that, this insight opened up a second dimension for numbers, the complex plane.
And on this new two-dimensional plane, multiplication suddenly gets a whole new geometric meaning. Multiplying a number by I doesn't make it bigger or smaller. Instead, it rotates it a perfect 90-degree turn. And this idea of rotation, is the key that's going to unlock our whole mystery.
So, we've met our four characters: Phi the artist, Pi the engineer, E the naturalist, and I the chimera. Now let's see how they all come together in one of the most elegant and frankly surprising moments in all of science.
Remember that mysterious equation from the start? Well, it's actually a simple set of instructions for a little journey on the complex plane. The E tells us we're dealing with continuous growth, which on this plane becomes a smooth continuous rotation, and the I pi tells us exactly how far to rotate, pi radians, which is 180 degrees. So if you start at the number 1 and rotate 180 degrees, you land perfectly on -1.
But the connections don't even stop there. They go even deeper, and they all come together in this breathtaking formula. Just look at this thing. It connects Phi the artist with E the naturalist, Pi the engineer, and I the chimera. All four of our characters, all united in one single, perfect expression.
You know, this just reminds us that the universe of math isn't just a collection of cold, disconnected rules. It's a world full of hidden elegance and structure and these beautiful relationships just waiting for us to discover them. It really makes you wonder, what other truths are out there just hiding in plain sight?